Yeah, so Siddharth, you can start.
Okay, great. So I will just start by sharing my screen again. Can you see my screen?
Yes.
We can
Yeah,
see your
okay.
yeah, we can see.
Okay, perfect. Okay, then I will start. So again, hi everyone. Now today we'll continue talking about ERC20 that we did last week, and also NFTs. But we'll of course see if there's time for it. Otherwise, we can do the presentations. That's up to you both. And yeah, so if we start, this was the original outline, and I added some stuff. But basically, last time we covered these three topics. We ended up at a decentralized autonomous organizations, and we didn't get to create a demo afterwards. So I'm thinking I can do a very brief recap of what we talked about then, and then jump to the demo and creating a market vendor for our token.
I think that's a good idea. Just
Yeah.
recap briefly and fastly. Otherwise,
Yeah.
Otherwise we'll be starting from the middle or something like that.
Yeah, I'll just do that, and I'll try to only spend time on the important things, right? So, yeah, so the idea is we'll cover this one, and then after that we can see. Yes, we talked about how ERC20 tokens, it's essentially a ledger, that it's not like Ether, and how if someone has 10 tokens, it simply means that a smart contract behind the token has actually written down the address and 10 associated with it. And we talked about how that was different and how ERC20 was a standard that was developed. So all the tokens on Ethereum can have a single standard. And we looked at what the standard is, and there were some requirements, such as name, symbol, decimals, total supply. And then we looked at the balance of function as well, which this is the smart contract with the ERC20 token, and balance of is a function on the smart contract that tells you how many tokens an individual has. So in this case, Bob wants to know Jane's number of tokens. So he contacts the smart contract and then gets 10. And we talked about some more, let's say, complicated functions in the ERC20 standard that actually allow us to do a lot more afterwards. So one was transfer, and the other was approve. Transfer was for sending tokens from one person to the other. Approve was to allow delegation, and allowance was to see how many were delegated. Of course, we'll look at examples really quickly. And then finally, we had the transfer from function, arguably the most complicated one, but the one that allows delegation to occur. So if we quickly look at transfer, as it states, if Bob wants to transfer 10 tokens to Jane, he contacts the smart contract and calls the function transfer. And then automatically the ledger is adjusted. So now Jane has 10 tokens, and she can check that using the balance of for Jane function of the smart contract as well. Similarly, we talked about approval, about how if Bob approves Jane to use 20, it doesn't mean that Jane actually gets 20. Bob still has the 100 after approving Jane, but it simply means that Jane can then actually spend on behalf of Bob, which we'll see in the transfer from function. And as you can see here, yeah, Jane, when she asks for the balance, only has 0 because she never got the coins. And but if you look at allowance, then she sees 20, which reflects the fact that Bob has allowed Jane to spend 20 on his behalf of his tokens. And then we looked at the transfer from function, arguably the more complicated one, where we have Jane, who in the last slide was given access to 20 of Bob's tokens. She then uses the transfer from function in the smart contract to transfer tokens from Bob to some other person called Dave, even though Jane doesn't own these tokens. And that's reflected by Bob now having 10 less and Dave having 10. And so we end up with Bob having 90 tokens. Jane still has 0 tokens because she never owned those tokens, and Dave now has 10. And we saw how that Jane is actually allowed to make another transaction, or however many she wants, until she hits the 20 limit that Bob has allowed her. So here she hits 10, so she transferred 10 of the 20 she was allowed to transfer, and here she's also transferring 10 from Bob to Ankit. And with that, Jane cannot transfer anymore. And we saw and we were going to discuss the usefulness of the transfer from function when we look at the demo that we are going to do later. And we had a small demo, which we'll actually use in the subsequent demo. And we talked about why we needed to use these tokens, or why people use them rather, and what are its possibilities, and how it can be used for stable coins or as governance tokens, and also how the ERC20 standard brought a standardization of tokens and also greater transparency as a result. And we briefly discussed what a decentralized autonomous organization is, and we had some discussion about it. And we talked about how it is a slippery concept and how there's always going to be some risk associated with it, and that if something is called a DAO, it's up to you to decide what qualifies as a DAO, because these words can mean a contradiction in terms if we have really large smart contract organizations where humans are, or where people are also involved. And after that, this is basically where we left off last time. So that's a quick recap. If you have any questions, of course, feel free to ask. But next, what we're going to do is we're going to actually try to implement another. We're not going to implement an entire DAO because we're not going to build an actual organization. It's also complicated to figure out when something is just a smart contract and when it's an organization. But again, we're going to take a simple example that we'll go to, which hopefully will show the principles of being autonomous, that it runs automatically without human intervention or a human having to do things in the background, and also the fact that it's decentralized. And we're going to do that by having that on the Ethereum blockchain. So it's both decentralized, and the smart contracts that automatically execute are going to be the autonomous part of it. So we're going to create, let's say, decentralized autonomous smart contracts. So let's look at the example that we wanted to talk about. So we talked about a market vendor for our token. So I'll just read through this and I'll then explain what it is I'm trying to do. So let's say we have a simple trusted market vendor. You can also go into what it means to be trusted, but we have a simple market vendor, smart contract, where users can come to buy the tokens by sending Ether and also sell their tokens back to the market vendor and then get some Ether in return, right? So this is not a marketplace. We're not matching buyers and sellers. We're saying that there is this one smart contract where if you want to buy some tokens, you can go there. If you want to sell some tokens, you go there. But all you're doing is interacting with the smart contract or with the market vendor smart contract. And we'll, of course, see how that we can do it. But before we go into it, let's talk about a few practicalities. To keep things simple, let's say that one token, the token that we created, the ERC20 token, is equal to 1 Ether in value. So if Bob wants to buy 2 tokens from the market vendor, he has to pay 2 Ether. Similarly, if he wants to sell the tokens back, then if he sells 2 tokens, he gets 2 Ether back. So that's kind of the functionality we need to build. And as another practicality, let's just assume that, and I'll do it in the demo, where all the tokens that are created are all sent to the market vendor. So the way we start is Bob or Jane or whoever, no one has tokens, only the market vendor has all the tokens. I think like a real life example could be how if you want to sell gold or buy gold, you can of course sell it to individual people, but oftentimes there is like a jewelry shop or like a vendor who actually buys the gold from you and then sells it to someone else who's interested. So yeah, again, this is just recapping what we were saying. So for simplicity, let's say if Bob wants to buy some tokens from Jane, Jane has to sell to the market vendor and then Bob can buy it. So they're not doing it directly. And then Bob can buy it from the market vendor and vice versa. So both only trust the market vendor and not each other. So I want to just talk about that. So why would we create a market vendor?
Maybe let me complement here to elaborate
Yes.
a bit. Probably Bob and Jane, they might be located at different locations of the continent or across different continents and things like that. So it's always a good idea to go through the market vendor, right? Because so, and also trust issues.
Yes, exactly.
Because they are not validated and things like that. Trust issues might also be one of the issues. Yes.
Yeah, definitely. So yeah, the trust issue is a very important thing, and that actually I think makes this example more practical because in the blockchain, you're operating in a trustless environment, right? And all the addresses are pseudo-anonymous. So unless you know someone, unless, for example, you and I know each other, and we actually know each other, and then I have a couple of tokens to sell you, then we can of course do the transaction. But if we don't have that, then it's really not probable to be able to transact, because that's when a lot of scams happen, right? Because you don't know who you're transacting with, and in that way, a lot of scams can happen. So I also, when we go through the example, I know I'm speaking a lot about the example, I'll show it soon as well. But when we go through the example, I think it makes a lot of sense to also think about who is trusting whom in this situation and how that plays out in the trustless environment that is the blockchain, right? So a lot of times people have been scammed, and there have been all these issues where they say, okay, you just transfer me the token, which of course simply is sending a function call to the Ether, to the smart contract, which has the ledger. And then they said that, oh, I'll transfer you the Ethereum. But in that situation, you have to trust that the other person will send you the Ethereum, right? And that's not always possible. So in these situations, we'll have a market vendor. And it's also a bit more realistic in that one of the most famous decentralized organizations is called Uniswap, where it is an actual marketplace where you are matched with buyers and sellers, and it enables that. And its popularity is also a testament or evidence that in a trustless system like this, having a market that actually does what it says is actually very important, and actually shows the value of it. Yeah. So now I think we can actually go further and look at how to develop it. I'll take some examples, and again, let's think of it in terms of the trust one. So there are two things we needed to do, right? One was buy, and the other was sell. So let's just take a simple example. Let's set it up. Let's say before buying, so the market vendor has 100 Ether and 100 tokens. So no one else has any tokens. And let's say Bob has 10 Ether and 0 tokens. And Bob wants to buy some tokens. So what can Bob do? So first of all, before I actually go in, let's talk about in what situations would Bob actually trust the market vendor, right? And the thing is, oftentimes when you have these decentralized organizations, what they do is they actually put up, they're actually audited. So people actually check their smart contracts, and oftentimes they actually put up, I'll just try to show an example. Just one second. What I mean by it. So let's say DAI stablecoin, this is something I talked about last time. Now, if you are here, they usually have a place where they have access to, they tell you where the smart contract is, but usually they also have the contract itself. Yeah, there we go. They usually provide you the contract itself, and then there's a contract source code verification. What this doesn't mean that the contract is not gonna scam you or anything. It simply means that the code at the smart contract address is this one. So they use a hashing function to basically hash all of this and then check. So this way they're verifying that the code that they're saying that they put in this one address, which is this one, is actually this code. So what is the benefit of that? The benefit of that is, as new people, we can understand code, so we can actually go in the smart contract and actually check for ourselves, right? To see if it's actually a scam or not, if it's legitimate, if it's actually doing what it's saying it's going to do. Again, this is not a completely foolproof way, because again, this is just Etherscan is like, it was run by the foundation, I believe, but of course, I'm not saying to blindly trust it, but this adds an additional layer of trust for the pseudo-anonymous people who use the blockchain.
And also, it's a good case of transparency, right? Like, because then you can, how do you believe that the smart contract, because the smart contracts will be in the compiled version and things like that. So it's also a good way to see what the code is doing and things like that. So yeah, yes. Then getting trust over it, yes.
Exactly. So that's the main thing. And I will go back to the example again. So now, let's say if we just go back to the example, let's say Bob, as a result of that, trusts the smart contract. He says, so when he hears that people are using this, he's like, okay, I'm going to look at the source code, and he sees the source code and he's happy with it. He's like, okay, this is not a scam. if I send 2 Ether, I'm not gonna lose it. And oftentimes, these smart contracts actually, the more popular they get, the more people trust them, because if it was a scam, it would have been found out by now, right? So Bob has a lot of reason to trust the smart contract. And let's say he's also done his due diligence and looked at the code. So he's actually happy to send it to Ether, right? And now we will come back to it, but we also have to handle the case where the smart contract has to trust that Bob is also not trying to scam it. In the buy situation, we'll get back to that point. If that feels a bit complicated or it's not clear, we'll get back to it when we look at selling. So in this situation, Bob wants to buy. So he says, I want to buy 2 tokens, and he sends 2 Ether. So the smart contract automatically gets the 2 Ether. So it knows that it can trust Bob because why? Well, he did send it to Ether. That's all the smart contract is asking. So what does the smart contract then do? It calls the transfer function for Bob. And what essentially happens is, it originally was 10 tokens, it goes down to 98, and Bob gets 2 tokens, right? And I just want to highlight, so after buying, what happens is Bob has 2 less Ether, but now 2 more tokens. Similarly, the market vendor has 2 more Ether and 2 less tokens. And I will just repeat one more time. It's interesting to note that here, Bob can send the smart contract Ether, right? But because these tokens are not like Ether, he has to actually do the transfer function. He can't just simply say, send 2 tokens to Bob. Why? That's because that's how the ERC20 tokens are, that it's simply a ledger. It's not actually a quantity like Ether that can be sent to different contracts. It's just a ledger that keeps track of it. So buy, I think, is quite straightforward. If there are any questions, of course, write in the chat or interrupt. But so as long as we understand the buy, which is a simple one, we can move on to sell, which I think is a bit more complicated. Yeah.
Great. Glad to hear it.
Yes. So let's move to sell. So now sell is actually a 2-step process. Why? Why can't we do it like we did buy? Well, the issue is that now Bob wants to send 2 tokens. But again, as I just mentioned, Bob can't just send 2 tokens to the smart contract, right? If Bob wants to transfer them, he has to call the transfer function. So Bob says transfer, and he says transfer 2 tokens to market vendor. So it's not as simple, or it's not as straightforward. So then we have to actually devise a 2-step process. So I'll first show you the process, and then we can discuss if there is another way of doing this or why we're justifying this process. So the first step that Bob does is, if he wants to sell 2 tokens, here we have what he does is actually approves the market vendor for 2. Now that's an important thing, because Bob now says, I'm allowing the market vendor to move 2 coins on my behalf. And the reason he's doing it, one of the reasons, is also that he trusts ERC20 token because of the reasons we covered in the last slide, right? So he just calls the approve function. And as we've seen before, approval is only for delegation. So Bob's Ethers are still his. So before he has 8 Ether, even now he has 8 Ether, 2 tokens, and he still has 2 tokens. Same with the market vendor, nothing has changed. Now, first Bob approves. And the second step is, now Bob actually calls the sell to function, right? And this is the thing that's going to be interesting to implement. But the point is that Bob says sell to, and then the smart contract, what it does is it actually transfers. It uses the transfer from function. It delegates the delegated function. So what does it do? It actually says transfer from Bob to itself for 2. And why? How is it able to do that? It's able to do that because Bob has approved market vendor to send 2 tokens on his behalf. So the market vendor just sends the 2 tokens to itself. So it says this, it says transfer from. And so now, what is it? Yes. So now the market vendor has started with 100 tokens, now has 102 tokens, right? And it loses 2 Ether because it paid 2 Ether back to Bob. So now Bob is happy and the market vendor is happy as well. But this setup only works because we're using the transfer from function. Yeah. And I just want to now quickly, if there's any questions, it's a good time to talk about it, because now I'll try to justify this design. And the first thing we can do is talk about, could I have done it in a different way? Well, I don't think it would be practical to have done it in a different way, simply because the tough part is Bob can't just send 2 tokens to the market vendor. He has to call transfer function on the ERC20 token smart contract, right? And that's the main thing. What that means is this smart contract will never know that Bob sent these 2 tokens to it, that Bob transferred these 2 tokens to it. Why? It's only a ledger that's maintained here, right? So for the smart contract to do that, it somehow has to have outside access to all the events that are generated on the token and read the tokens and read the events. And that's really not practical because all that data has to be put back into the smart contract and it has to keep track of it. And that's really not a practical solution because for a single person, it has to somehow figure out how to do it, and it becomes really complicated and also not practical. And then, yeah, I think that's the main reason. And the second, so let's talk about trust in the situation, because I talked about trust in the last buy there, where Bob just trusts market vendor, and market vendor trusts Bob simply because he did give the 2 ether, right? So in this situation, how is the trust established? Well, Bob already trusts the market vendor, as we've talked about before. Now, the market vendor, using this kind of 2-step process, doesn't have to trust Bob. So the market vendor doesn't have to trust Bob if he says he's transferred to, right? Because why? Because the market vendor himself is doing the transfer. So if Bob didn't approve the market vendor to transfer, this operation would have failed, right? And then he would not have sent the 2 ether. So this way, the smart contract is also, let's say, it doesn't have to actually trust Bob. It just does it. And now we'll look at how to do that in code. And hopefully, I know this might sound a bit complicated, but we'll look at the code and hopefully it'll become a lot more clear. So yes, we'll now look at the market vendor demo. Unless there are any questions. Should I wait for questions?
Meanwhile, if you have any questions, please put it in the chat. I'm also watching the chat, and yeah, if you have any questions, we will answer it.
Yes. Okay, so now
I think once we go through the code, maybe we'll have a better idea.
Yeah.
Right now it's a little confusing.
We can understand that. Yeah, it's a bit abstract situation. Let's go look into the code, and then if necessary, we'll come back to the slides and maybe repeat. Siddharth, you can repeat what you said. Maybe you can increase the size a bit, Siddharth. So
I think, is this better?
Yeah, it's good. Yes. Yeah.
Okay, so so this is the code for the ERC20 token. I'm not going to go through that. We talked about some of the different ones like transfer, approve, transfer from. Now let's just look at the marketplace. So the marketplace imports the token that we created. And what we're saying is so we're going to have a token that's of the type our token that we created before. And in the constructor, we actually pass in the token address where our constructed, so this token has a smart contract, right? And we'll deploy the smart contract and it will be deployed to an address. So we take that address and then we pass it to the constructor. So the token, we know where the token basically is. So why? Because we need to be able to call the transfer functions, transfer from functions, approve functions, and all that stuff. So this smart contract needs to know where the token smart contract is. And this is the one way we're passing it, right? So now let's just look at buy token, which I think is the more simpler one. So let's say the message sender is Bob, and he sends ether. And what we're saying is we have something called a buy token, and we have an amount. The amount specifies how many tokens he wants to buy. And it's a public function because we want anyone to be able to call this function. And we have a payable function as well. Why? Because we need to be able to receive ether. Why do we need to receive ether? Because to buy the token, you need to exchange it for the ether. So the first thing we do is if we check if the amount of ether sent, what this is, so message.value will actually have how much ether you're sending in weight, which is 1 divided by 10 to the power 18. So we are basically just converting however much value they sent in weight to ether. And we're saying we need the amount of ether sent to equal the amount here. Why? Just because if you want to buy 2 tokens, you need to send 2 ether, and that's all this is doing. So you're not providing enough ether. So let's say they ask to buy 2 tokens, but only send 1 Ether, you will get this error. You're not providing enough Ether. So now let's note down how much it is that they want to buy, just tokens to buy. Not necessary, but I'm doing this to be clear. So it's like, let's write number of tokens. And what we're doing is now we need to see that there are enough tokens in the reserve for the smart contract to be able to transfer, right? So what it's saying is token.balanceOf function, and I'll just open it on the side here. So this is our ERC20 token, and we have the balanceOf function that we talked about multiple times. I don't think I need to find it, but yeah, balanceOf function, yes, you will, it's because it's here and it creates a function. So what we're basically asking is, to the token, we call the balanceOf function for this address. So the smart contracts address, right? So checking if the smart contracts address has enough tokens, right? And what I mean is, let's say the vendor only has 20 tokens and you're willing to pay for 30. Well, this one will then say that, okay, well, we don't have enough tokens, so we're gonna revert. So that's what the require function does. So if this is also fine, so let's say you're interested in buying 2 tokens and the smart contract has 2 tokens, then it's good. Then we go on to the next function, which is token transfer. So we are transferring from the message sender. Well, we're transferring to the message sender. So message sender is Bob. So we're going from smart contract to, or I'll just write market vendor instead. Market vendor to Bob. And that's what this is doing. Simple transfer function that we've seen before as well. It's the destination of who to transfer it to, which is Bob, and who's the one who called this function, and then the number of tokens to buy. It's the same function that we saw last time as well. So this is a straightforward one, and of course we'll see a demonstration as well. And I do hope it will get more clear. But now let's look at the sell token function. That is a bit more complicated. So if we look at the sell token, what are we saying? So the sell token must have first approved the marketplace, or should be market vendor. Approve the market vendor to transfer a certain amount of tokens beforehand, right? It's the approval that I talked about. In the sell, it was a 2-step process. One was approval, and the other was actually the transfer from that is being done. So we're going to check 2 things. First, we're going to check if the marketplace or the market vendor is allowed to transfer however many tokens that the person wants to sell, right? So we look at allowance, and of course, what is allowance? It's the same function here that tells you how many tokens you can actually transfer on behalf of someone else, the delegated transfer. So what we're asking is token allowance, message.sender, and this. So how many tokens is message sender? In this case, let's say it's Bob. Message sender. So how many tokens message sender has allowed this address? What is this? When we say this, it equals the market vendor. Yes. So we're just looking for one of the main conditions that we need. We need the market. We need Bob to have pre-approved the market vendor to transfer a certain amount of tokens, right? And that's what we're checking. So if that doesn't happen, we're just going to return an error. We're going to revert and return an error saying marketplace not approved to transfer this amount of tokens. Okay. And the second one is then we need to look at the balance of the message sender, right? So now what's happening in this case, Bob is saying, I want to transfer 2 to you. But the second check we're going to do is actually check if Bob actually has 2 that he can transfer, right? Like that's the easiest way to scam someone. If you say, well, I'll give you 2, but so you give me 2 Ether and I'll send you 2. So that's what this check is about. So what is this check doing? It's simply saying that a balance of Bob should be greater than or equal to the amount. So it's a 2, right? So if he's calling this function with sell token 2, then his balance should be more than or equal to 2, right? Not enough tokens to sell. Yes, and then if that happens, here is the place where we do the transfer. So the token that we have here. So we're calling the transfer from token on the smart contract. And what we're saying transfer from the message sender, in which case, who is that? That is Bob, right? Talked about it, message sender. And we're saying transfer from Bob to this address. What is this address again? It's the market vendor. And we're transferring an amount of 2 tokens. Yes. Yeah, so once this is done, so now this is an interesting step, right? So this is the one where the market vendor is actually going to try to transfer 2 tokens to himself or to itself, to the smart contract. And if this doesn't work, of course, it's going to revert, right? So let's say Bob hasn't allowed it, or we've actually asked some good questions here. So at this point, he is allowed and he has the balance, so this function would work. But in case something doesn't work, then it goes back. So finally, the final step is then we actually say payable message sender, the address. So that we're talking about Bob again here. And we say from market vendor, we're actually going to just transfer. And this is not a transfer on the token. This is just an Ethereum transfer. Why? Because he sold 2 tokens and we're going to send him 2 back. So this is actually, I'll just note it down here. This transfer. Yeah, it's an Ether transfer. So from the market vendor.
So it's it will transfer the equivalent amount of the Ether, right?
Yes.
Like if it is 2 tokens, it will transfer 2
Yes.
Ether.
Exactly, and that's what this is doing.
So the main issue here is the main point to note down here is the market vendor, which acts as the intermediary between the buyer and seller. On one hand, he is guaranteeing both parties that okay, things will go fine, or he will be responsible for making the transfer of money to Bob and also the tokens to the buyer. Yeah.
Yes, exactly. And if we didn't have a delegated function like this, and that was also one of the main reasons to have transfer from function. If we didn't have delegated ones like this, then this setup would not really be possible. Like you wouldn't, then the market vendor has to trust that 2 tokens has actually been sent to it, right? And that's not really feasible for like an autonomous smart contract to do. So of course, if you're an individual person and you say that, okay, I'll send you 2 tokens and you see it, you can of course check balance and see that it rose by 2 and then you can transfer it, right? But it would not be really possible to do it autonomously like this and also verify it like this without the transfer from function.
And again, if you look into the, go ahead. Yeah.
So can we say that we are making a sort of like a proxy escrow mechanism kind of thing?
Yeah. Exactly. That's
exactly. Yes.
Yeah. So that is what this is. And the good part about the escrow is that it's not centralized, right? And that's why this works here. It's that in a decentralized setting, it's an escrow that is trusted, or it doesn't have to be trusted because you can see what the code is.
That's the main point. So this is a good example of the approve and transfer from and things like that. And this also guarantees that the both parties, they cannot cheat, right? Either one party cannot cheat, or even Bob, he might say that, okay, send me the Ether. If we don't have a market vendor as a market vendor contract in between Bob and the buyer, right? And then he might say that send 2 Ether, and Bob can cheat without transferring the coins and things like that. So the market vendor is the one which is, of course, it's a decentralized contract and things like that, but it at least makes sure that things are happening almost autonomously and things like that.
Yeah, exactly. If there are no more questions, we can continue with the demo, and I'll actually show this in action. I'll just do it, and I'll just, of course, if you have any questions, just feel free to interrupt. So I copied the code, and now I'm gonna go to Remix. Yes, and I already have it in Market Vendor, but I'll just copy paste the new code. Yes. So now I'm gonna try to show this Market Vendor working in action. But the first step we need to do is actually we need to deploy the ERC20 token that we have. This is a token we talked about last time. and I'm just going to compile and then deploy it. Need to start Ganache first. And we're going to keep our own ledger and stuff like that here, just to keep track of what's going on. So, yeah, okay, we're starting. So first we need to keep track of where the ERC20 token address is, and then market vendor address. Okay, so now, yes, so Ganache is now working. So I will now just deploy. Firstly, I'm just going to deploy the ERC20 token. So it has been compiled, and now we have to choose the right compiler. It has been compiled, and now we're going to just connect to Ganache. The reason I'm going so fast is we've seen this before as well. Yes, and we're going to click deploy our token. And when we deploy, we have to specify a total supply. This was something we talked about last time. So now I'm saying we're deployed and we have total supply of 100 tokens. So before I just move on, it's the, if we remember the constructor, all the coins or all the tokens go to the message sender. So in this case, let's call this guy Bob. In this case, we'll look at Bob, and let's just put his address, and then let's talk about his ether, and also the number of tokens. So he should have around 100 ether and 100 tokens. So let's just, that's our first step we're gonna do. We're gonna check if Bob actually does have 100 tokens. So we take his address, and then we go to where the thing is, where our contract is, and we're gonna say balance off. It returns 100. If you can't see it because it's too small, you also get 100 here, right? So that means that this is correct, that at least, yeah, Bob has 100 tokens. And for Ether, we can see here that he has almost 100. It will, of course, be less because he's just deployed the contract and stuff, but basically 100. For our sake, we'll just say it's 100. Now, the next step, so this just shows that all the tokens are here. So we're just going to continue with the more setup. We haven't started anything yet. So we'll go and we're going to compile the market vendor as well. And yeah, we're going to call him token vendor. That makes more sense. And as I said in the constructor, we need to give the address of our token, right? So we have to find, so the first thing is we need to find out where the address has been deployed, or where the smart contract for the ERC20 token has been deployed. Created contract address is here. Just take that. And of course, there are multiple ways to figure out. You can also see it here as well. Like you can see where it is. So ERC20 token address is this. And now we will then create, we'll just pass it to, let's just double check. That is the correct address. Yeah, it's the same address. Okay. So now what I'm going to do is now I'm going to actually continue with the setup, which is to now deploy the token vendor. So we're going to give it the address of the smart contract, and we're going to click deploy, and it worked. So let's just double check. If we go to transactions, another contract has been created, and we're going to take down the contract address of the market vendor or the token vendor, which, yes. So I hope this is clear so far. It's still doing setups. So now I said that for practicality reasons, I'm going to make it so that in this example, the market vendor is the only one who has all the tokens. So, but currently only Bob has all the tokens, right? So what I'm going to do is we're going to transfer this to the market vendor, and that'll be our second test. So right now the market vendor has 0 ether and also has 0 tokens. So we're going to do that. So the way to do that is I go to the token that we have, the ERC20 token. We're just going to make sure it's Bob. That's there. Yeah, and it is Bob that's there, AB, and ends with 04. So what we're basically saying is we're going to send some tokens to the smart contract. And to do that, we're just going to call the transfer from, or transfer function, not transfer from. So we have a recipient. Who is going to be the market vendor. So we copy that address and say address. and then amount, let's transfer all the 100. So now I'm just going to click transact, and it worked. So now let's check again. So we have the market vendor we've copied the market vendor, and now let's see the balance of the market vendor. It should return 100, and it does. So which means that now the market vendor has 100 tokens. Let me just update that. So the market vendor previously had 0 tokens, still only has 0 Ether, but now he has 100 tokens. And Bob previously had 100, and now he has 0. Okay. Now we can continue. So now let's choose some other people. Now we're actually almost done with this. And now we can actually show the functionality that we talked about, which is buying and selling. So let's say that we actually buy some tokens, because clearly the smart contract does not have any Ether. The smart contract has 0 Ether, so it can't really sell, that you can't sell any tokens to the smart contract. And also all the supply is 100, and the market vendor has all the supply. So what we're going to do is we're going to run some buying functions. So let's choose another address. Let's say this is Jane, and we're going to write that down as well. Yeah, so we have Jane who has 100 Ether, but the tokens are 0. And now Jane wants to buy, let's say 5. So if Jane buys 5, what do we expect to happen? We expect her Ether to go down by 5, so ends up 95, question mark, since we've not tested it yet, and our tokens to go by 5. Yes. And if that happens, what do we expect for our market vendor? Well, the market vendor will now also lose 100 of their tokens, or no, 5 of the tokens. Previously used to be 100, and now it goes down to 95, but in return gets 5 Ether, right? So that's going to be our test. So I'm just going to put question marks to show that that's how it is. And we can do our first function call. And it should be a straightforward one. We just have to send, when we want to call the buy token, we just have to send Ether that has to match the amount, and that's it. So here we have Jane, and Jane is now going to say that she's going to send 5 Ether. So we just raise it by 5, and then say buy token 5 contract, and it actually worked. Or at least it went through, and now we can actually just look at the logs, because we will actually see. So in the logs, it actually says that there has been a transfer from AD. Let's see who that is. Yes, that is our market vendor. Oh, it's actually not clear. Second. Yes, it's our market vendor, has transferred to B5F, which is Jane that we have here, and has transferred a value of 5. So it seems like all is working. So let's just do our quick test. So now let's go back to the token. So this is our ERC20 token, now the market vendor, and we're going to look for Jane's balance. Let's copy Jane, look for a balance, and it's now 5. And it's the same thing here. So now she has 5, and that worked. And we can quickly see how many tokens she has, or like Ether she has, and it's 95, close to 95. So that worked. And now let's quickly also check how many tokens the market vendor has lost. So we can clear the question marks from these, and that worked. So now we're just gonna choose the market vendor's address, or token vendor, whichever one we call it, and we're gonna look at their balance. It's 95, 95 here as well, which means that the buying has been successful. So Jane has bought 5, and now the market vendor should have more Ether as well. Now for that, I actually created, so this is the market vendor contract, and I created a get balance one. It's not necessary to see it, but this is a way that we can test. So let's go to the token vendor. And honestly, if you see it here, it already tells you it has 5 Ether, because the Remix already does it for you. So this is nice to see, but yeah, we can just do that as well. So get balance. And it has, yeah, it's going to be 10 to the power 18 zeros, because it's in way, but this basically means it's 5 Ether, and we can confirm it here as well. So far, so good. So now we can move on to the selling part of it. So the selling one is a bit more complicated, right? So now Jane has 5 tokens, and now let's actually write down what we want to do. So Jane has 5 tokens and she wants to sell 3 back, right? So in this situation, what should happen? Well, if Jane sells 3 back, she should end up with 98 ether. She should get 3 ether back. And her tokens similarly needs to decrease by 3. So her token should be 2, right? And similarly, the market vendor, we'll just remove this here. So the market vendor will actually lose some ether, right? It's going to lose 3 ether, so to come to 2, and it's going to gain 3 tokens to go back to 98, right? So that's what we are assuming. So let's also do that. So in this case, what are the things we need to do? First, we have a 2-step process, right? So one is Jane has to approve a market vendor to transfer 3 on her behalf. So let's do that. And then next one is we have to then say Jane calls sell token. I think that's the name of the function. Yeah, sell token with 3. So let's do that. So let's go. So the first thing we have to do is when Jane wants to approve something, it has to, of course, be at the token itself, the smart contract of the token. So let's just remove all of this. It's not necessary, but yeah, so we say approve. So in approval, we just make sure that it's Jane we still have here, and it is. Jane is the one with BF, yes. And then we're gonna take the address of the market vendor and we're gonna approve it. So Jane is gonna approve the market vendor to spend 3 on her behalf. And that went through. And there's a way to check that. We just have to look at allowance. So we look at allowance. So we see we're going to put market vendor here. So we're basically seeing how many tokens does Jane allow the market vendor. So now we have to go back and we don't have to go back. Yeah, I guess we can. So we have to go back here and then see how many it is. And we're expecting 3. And yeah, there's 3 here as well. So that means that 3 can be done. So we did the first part. So now let's go to the second part, which is that we now say sell token. So Jane is going to say 3, and it should work. And at least a contract went through. And let's look at the logs. So if we look at the logs from Jane, this is Jane, to the smart contract, and 3 has been transferred. And the main part is this is fine, but we have to make sure that Jane also got paid. So let's see how many. Let's see what Jane's ether balance is. I'm going to just pull out Ganesh for that. She has 98, right? This is Jane because it's BF5, and she has 98, which means she has resold 3 of the tokens back. And we can then quickly just check the balance of the smart contract, so we can actually ensure that the number of tokens is 98. We can also just quickly look at the token balance, or not token balance, the ether balance, and it's 2 ether. So clearly 3 has been gone. So we're just going to look for the balance, and it should be 98. Oh. 98, yeah, there we go. That's what I needed. And we get 98. So that just shows that the functions have actually worked. And that was most of what I wanted to show for the vendor thing as well, unless you have any questions or any discussion. So I think one thing that could be nice to just think about, you don't have to actually talk about it, it's up to you, is could we have done the sell in a different way? My question is, could we have done the sell in a way that's different? Because it's quite different in that we have a 2-step process. Could we have done it in 1 step? And what would it take to do that?
I think there are some groups who are done a bit more coding as well. So yeah, maybe you people can try to answer. So already people who have worked on the smart contracts and things like that.
Yeah, students, you can share your experience.
Would it be like the deposit and the sending of tokens happens in the same function? Does that work?
I mean, I'm trying to think how that would work. So you're saying that the approval will be also done through the smart contract. Is that what you mean?
Yeah.
Yeah, I don't think that would work, because if we look at the approve function, if we look at the approve function, right, it looks at message sender. So if we do it through the smart contract, the message sender will be smart contract, not actually Bob that we want.
Okay, got it.
Yeah. Yeah, I think there are no more questions. That's okay. So I don't know if we're continuing with this or it's going to be presentations.
I think if you have a code on the NFT tokens, then maybe you can also present that. So then you don't need to come on another day, right? So yeah.
Yeah, I can do that. Yeah.
So maybe we
Yes,
will
sir. I think we
ask
can
if there are any
continue
questions.
with the lecture.
Yeah. Definitely, we will do that. And before that, are there any comments or questions about the market vendor code and how we implemented the ERC20 token and things like that? Of course, this is a simple example where we have implemented with some very basic functionality, but it could be, this is the overall skeleton, right? It could be easily expanded with a lot of validations and a lot of internal things and other kinds of stuff. So it can be easily expanded.
Yes, I just have a doubt. What was the need for emit in the functions used? Like, how do we play that?
Yes, I will just show you with an actual example. So we just go back to, not this one. Yeah, if we just, we're here, right? When we looked at, I'm just going to try to close these down. When we do any transferring and things like that, this is why. So when you say emit, you actually get this information in the logs. So this one says event is transfer. So if we look at where that emit is, yeah, this one, emit is transfer. So it's either
emit is a keyword, right? Keyword for the events. It's like a it's like a rise keyword in case of other programming languages. When you want to throw an event, you know about event and subscription model, right? Like the producer will throw the event or raise the event. And normally how it works is you can sign up or you can subscribe for the events, and the consumers who are interested to see that, and they can get the event in notification. So that's that event mechanism.
Yeah, exactly. So if you want information in the logs, you have to emit it, use the emit keyword. Yeah, and the reason people use
and
these
also events.
Go ahead.
Events are quite important in many situations, and then probably you might have a downstream flow or downstream business logic based on this event. For example, let's say that you might have another contract or something like that which might have signed up for this event, and maybe when this event gets notified, and then the smart contract may do some other business logic function or something like that. So yeah, there are many several use cases for the events.
Yeah, and it's also a pretty, let's say, lower cost way of monitoring how the smart contract is doing as well, or what's happening in the smart contract. Instead of keep reading from or calling the smart contract to give you information such as balance off and things like that, you can also just note down when something changes and keep a record of that in like a simple database. That's also one thing.
Got it. Thank you.
Yeah. Cool. Okay. I think,
any other questions or comments? Yeah. Then maybe we move to the NFT tokens.
NFTs, yes, I'll do that. So yes, we just finished market vendor, and now we're going to talk about NFTs, which simply means non-fungible tokens, right? So again, the keyword is tokens that we have to remember. So we've just seen some different form of tokens, and now we're going to see a different form of the same similar tokens, right? And yeah, I'll explain what non-fungible and stuff means and how it differentiates with the kind of tokens we've seen so far. Yeah, so what is fungible? That's the main thing, right? So the definition I found was simply that fungible is anything that can be readily interchanged for another of like kind, right? So what does that actually mean? And before we talk about ownership, like the 100 rupee note, for example, is fungible. Like there are a lot of 100 rupee notes and each one can be interchanged and it has the same value, right? It has the same value and it's basically the same thing. It is completely interchangeable, unless of course you rip it or something. But in general, if you don't, then it's completely interchangeable. Similar to Ether, right? Like if you have 2 Ether and then we exchange Ethers for some reason, it's not that I'm having your Ether. We both have 2 Ethers and they're easily interchangeable, right? So all currency, most of the tokens we've seen, or all the tokens we've seen so far in the course have been fungible tokens, right? And that's quite simple because the tokens themselves were just written on a ledger. So all the tokens were the same. So if you sent me 2 tokens, well, it's the same 2 tokens and they can be easily exchanged. I also think I'll actually come to the ownership in a bit. So if we look at what non-fungible means, well, we can take something like the painting, right? So this is the Starry Sky. So this painting, there's only one of its kind, right? In the whole world. You can of course make replicas of it, but you can't interchange the real thing with the replica. That doesn't work, right? So the main thing about non-fungibility is that it can't be interchanged. It's a one of a kind, it's an original. And oftentimes any artwork that is created is of course a one of a kind, and anything, so you can of course take pictures of it and you can say you have the painting or the picture, but you don't have the real thing. So there's a distinction between what the original thing is and what the replicas are. And similarly with price, right? Like this one, maybe some millions of dollars, but a simple replica you can buy for like 1,100 rupees or something like that. And the other thing, an example of non-fungible is like a Tata Nano car that we have. So of course, when you buy a car, you have a registration and you have the registration plates and license plates and things like that. So you know that the car you got is yours and it's registered. Now, of course, there can be other of the same cars, right? So let's say you have a red Nano and let's say you and I exchange the Nanos. Does that mean that they've really been exchanged? Well, not really, right? Because your one will have a different license plate, will have a different registration number, and I'm sure a different signifier, even though they're both the same cars and the same color and everything, right? That means that it differentiates them. So non-fungibility is it simply means a way to differentiate and to say that, okay, this token is a one of a kind, it's like a unique one, and you're going to have ownership over it. So if we think about ownership with rupees or Ethereum and things like that, or Ether, like the ownership is basically whoever has it, right? Like if you have a 100 rupee note and someone takes it and you give it to someone, then it's theirs, right? And similarly, you can also do the same thing in non-fungible assets. It doesn't mean that the person who created it, who owns it, needs to own it forever. The paintings can be sold. This car can be sold, and then you change the registration and things like that. So it simply means that it's not exchangeable or readily interchanged. Yeah, and I think hopefully I've given enough examples, but of course we can discuss that further as well if there are questions. So the first question could be like, what is the point of an NFT? Like, why should we have it? The main reason for having it is it proves ownership of digital content, right? So what do I mean by digital content? Digital can include images, videos, and etc. The main thing for it is that it can be used for copyright, right? So let's say you create an image, you took a picture or something and it's yours. You can actually use it in the NFT to actually prove that you own it, right? So ownership, so first of all, it can be used for copyright. So let's say you create an image and then you put that image on the blockchain first, and you're the first one to do it, and then you put, and we'll get to what I mean by putting it in the blockchain, right? So you're the first one to do it, and it's yours, and then you can say that, okay, look, on the blockchain, I created an NFT for it, I'm the owner, and it's the first one that's been created. So then even if someone else has can get the same image as you and tries to put it on the blockchain, they of course can, but it's very easily seen who was the first person to do it, right? So that's one way we can use it for copyright or ownership. So this way, if you say your address is the one that has created an image or a video or a painting, then the ownership can be verified by anyone in theory. I say in theory because obviously you have to be connected to the Ethereum node and things like that, but otherwise that's what I mean, in that anyone can do it. Like anyone who has an account and is willing to check the ownership can check it. And another important thing is once you have established ownership, then it's on an immutable ledger, so it can't be changed, right? You can of course transfer ownership, and we'll see how we do that. But once you've established that you yourself own it, that can't be changed unless you want to. So as an example, let's say you create a new drawing or painting that no one has ever done before. Well, before you put it on the internet, you can actually create an NFT related to it and then put it on the internet. So even if other people look at it and copy it and claim that it's theirs, you can say that it's not, because this link where this image is actually related to the NFT. And I've created it first before all of these replications and fakes came about. So it can be quite powerful and useful, and it's also seen a lot of popularity in the Ethereum blockchain and the Ethereum space. So unless there was any questions.
For example, even people have created, I think the first tweet was also put on a sale and things like that, and then they created an NFT for it. So of course, everybody can see what is there in the tweet and things like that. There is no secret about it, but everybody can see it, and maybe other things, but only one person owns it, right? Like so that is the NFT part. Maybe people can use it, but on the other hand, you are trying to establish that you are the owner of this one, or some authority over that asset or something like that.
Yeah, exactly. And so I guess the next question is, so we talked about content, said images, videos, anything. Like, how do you connect the content to the smart contract, which is the NFT, right? Because we've talked about how tokens are simply just smart contracts. So there are multiple ways of doing it, and I'm going to try to talk about the benefits and drawbacks of each one. So one option is we just put the entire content. So let's say you created a drawing and you create it online. So you just take that image and then you put the entire content on the blockchain. So, and of course you can do that. You just have to encode it into base64, and then you have an image that's in a bytes form, and you can put it on a blockchain. And that way anyone can actually download that and then recreate the image for themselves, showing that you're the one who created it, you're the one who created it first. Now, the issue with that is, of course, content and putting a lot of content on the blockchain is very expensive. And it's quite clear why it's so expensive. It's because by definition, blockchain has nodes that have to replicate everything. So if you put up a simple image, which doesn't take too much space, remember that it's being replicated n number of times, where n is the number of nodes in the whole world. And that's also why it's so complicated, or so expensive, not necessarily complicated, but more expensive. So ideally not the best use case, and especially if the data grows. So we're now talking about image, but it could also be a video. You can create an entire movie and say you want to establish ownership. Then you can't put all that data in, right? That'll be ridiculously expensive. There's another option. The second option is to save the URI, which is the Uniform Resource Identifier, of the content on the smart contract. What this simply says is you host that content that you created, like a drawing, on your own website or someone's website. But what you do is you take the link and then put the link in the smart contract. So anyone knows that this is the first time this drawing has been created, and it's linked here, and the ownership can be verified directly on the smart contract. So you save, let's say, the URL of it. Again, there are of course some challenges, like you have to figure out ways of dealing with the fact of what happens if the website comes down, and what about if the URL changes and things like that. But quite frankly, this is the most popular option. Like a lot of people are using this kind of option for it, and they use it.
I will talk about it a bit later. Yeah.
Okay.
Go ahead with the
then I'll
third
just
option, because I will put some examples for the option 2 here.
Okay, I'll do that. So if we talk about option 3, so we have the other option could be use another blockchain, right? If you want it to be truly decentralized, or not just decentralized, but truly on the blockchain, you can use another blockchain that is geared towards data storage, because the Ethereum blockchain is geared towards computation. right? So it's also possible that there's other blockchains that try to optimize towards data storage and data space. Yeah. And in this situation, again, the benefits are that everything is on the blockchain in one blockchain or the other, and it's easily verifiable where the data is. But again, it's the same issue with blockchain, right? All the data has to be replicated somehow, or to some extent. Some data at least has to be replicated to some extent, which obviously means it's more expensive to do things and to store stuff on the blockchain.
Yeah, so regarding option 2, so the first option is very less used in the blockchain applications, right? Because very seldom you have a small content to be saved on the blockchain. Many times you have the certificates and images which contain megabytes and gigabytes of storage and things like that. So one of the popular approaches is the second option. So how do you make sure that somebody is not tampering the content which is stored outside the blockchain? So what you do is, even when we did it in our projects and things like that, when we implemented, you store all the data which you don't want to store on the blockchain at an external database or external resource or whatever it may be, cloud or something like that, which is easily accessible. And then what you do is you also take the hash pointer for the data and put the hash pointer and the hash pointer information and the URL as part of the blockchain transaction record. So what is the advantage you get by it? So since you have a hash pointer, so you can easily verify whether somebody has done or changed the data on the external source. For example, database or a website or something like that. That helps us to eliminate. And another example which I can give you, where maybe you don't have a lot of big files or big amount of data to store, but you might also have the compliance or the, for example, regulation and compliance, which might be preventing you from putting the data on the blockchain. Let me give a concrete example. In Europe, we have this GDPR called General Data Protection Act, so which protects the European citizen from in exercising their rights. So, for example, if a European citizen wants a company to forget about him, so that means this is the right to be forgotten. We call it as right to be forgotten. And if he exercises the right to be forgotten with the company, and the company or the organization, it has to delete all the information about him. So that means he can exercise this power, saying that, okay, I don't want you to keep any information about me. Of course, there are some exceptions. If it is like a bank and other kinds of things, they keep track of information, even though if you are not a customer and things like that, for financial regulation purposes and things like that. But in case of, for example, companies like Facebook and social media websites and all other companies, non-critical companies, they have to comply with the GDPR. So that is the reason why when we did this blockchain projects and things like that, we didn't put the names and information, personal information of the customers and the users on the blockchain. Why? Because if somebody wants to exercise their right to be forgotten, we have to delete information from blockchain, which will break the linkage between the nodes and other kinds of things. So what we did is we put all the personal information into a database, and we put a hash pointer to the database and data location and things like that. And then you can verify wherever that the data has not been changed and nobody has cheated with the external data source and things like that. On the other hand, if somebody says that they want to use the right to be forgotten, what you do is you delete the data from the external database. So the database information will be gone, and you still have the hash pointer on the blockchain, but that will be a null pointer. It doesn't reveal any kind of personal information. So this is one of the ways to solve the challenges of compliance and regulation in many cases. So the second option is quite popular. Of course, you can also go with the third option, where you have another blockchain. Maybe that is not very large network. It could be replicated across a few background networks and things like that. For example, hash-based file storage systems and all other kinds of things are a good example for the option 3. Siddharth, you can continue.
Yeah. Okay. Yes. So yeah, now we've discussed some of the options, and then we can look at how to implement the NFT. So yeah, there's something called the ERC 721 standard, which is by far the most popular one to use for NFTs. And but one thing to note is it's not the only standard. There's of course ERC 1155, which allows you to do both non-fungible tokens and fungible tokens as well. And yeah, so ERC 721 standard is a widely used one. And if we look at the functionality that we have to do it, you can see that it's quite similar to what we've seen for ERC20 token, right? So there's something called transfer and approval, and then there's something called approval for all, which I'll come to in a bit. But let's just look at some of the things we've already know. We know what balance of is. We know what owner of is that we've seen. Balance just gives you, who it is, but this will be interesting in terms of the NFTs. And there's something called safe transfer from, which we'll get to. But we've seen what transfer from is. We've seen what approve is, and get approved is a new thing, and set approved for all and is approved for all is a new thing, right? So like before I move on, I created a demo for this where I had only one NFT per smart contract, right? So I have one smart contract and it only has one NFT. Now that works and people have done that, but oftentimes a more useful thing is to have multiple NFTs or multiple tokens within one smart contract, right? Because unlike ERC20, with an NFT, there's only generally one owner, right? And that's where a lot of these other things come from. So in a single, let's say, set approval for all, let's talk about what that is. So let's say in a single smart contract, you have 3 different NFTs. You can have that. And then you can then say set approval. So approval, as we understand it before, it's just delegating or allowing someone else to move the ownership of the NFTs or to move the tokens in the ERC20 that we've seen. In this case, set approval for all just says that if you give it an operator or someone who's going to do it on your behalf, he will then be able to transfer all the NFTs that you own, right? So if I call this function and I say this will be you, then that means that you can actually transfer all the tokens. So, I mean, before I move forward, I just want to take a second to just think about why this is, right? So we've talked about how NFTs are like paintings and things like that. So let's go with that analogy. So oftentimes, if you have a lot of paintings, I mean, I don't own any paintings, but I've seen that when people own paintings and they want to sell it, they don't usually go and sell it individually, right? They usually use an intermediary, and that's what this operator is. So this operator could be someone who then takes these paintings. He doesn't own them. He just takes them and sells them, right, in an auction or things like that. And that's what this is. So when you say set approval for all, you're giving this operator a right to transfer all the NFTs that you own in the smart contract. And is approved for all is also just a way to check it. So let's say I own like 2 NFTs in a smart contract, then I approve you, then you can actually see if I've actually approved you by calling this function is approved for all, where it's the address would be my address and this would be your address, saying that the operator has been approved to transfer all the NFTs belonging to this owner, right? And of course, we have our normal approved one, which we can still use if we only have one token, right? But I'm just trying to show that there's a lot more implementation. And the thing with NFTs is given that there's a lot more implementation here, and given how it's used, it's hard to come up with a single smart contract that shows all the functionalities. So I've narrowed it down, and I'm going to show a smart contract where we have only one token for the smart contract, and we're going to look at how to transfer it and see how it is. So we have 10 minutes, so I'll quickly get to it. I would highly suggest just looking at the code if we don't go through all of it. But let me just start by it. So if we go into ERC20, we have I'll go to the new one. So we have the ERC 721 interface. This is what we just saw. And now let's go through the actual contract. So this will be very similar to ERC 20.
Maybe zoom it a bit so that
yes.
Yeah.
Oh, yes. Is this enough, or should I zoom some more? I think yeah. So again, it's similar name. Okay. So we have the name, we have the symbol, as we've seen before, and of course we also have a single owner. So before you had a whole dictionary of owners, right? If we look at ERC20, we had a mapping for balance of, where basically it's about mapping an owner to how many tokens they have. But here we only have, it's only one. So we only have one owner of it. And because we're only using one token, I'm going to say we have to give it a token ID. I'm going to give it token 1. This doesn't have to be unique throughout the blockchain. It just has to be unique in the smart contract. And we can have the URI, Uniform Resource Identifier, that we've talked about, which links to an image. And we can also have a token approval. What token approval is similarly saying that you're delegating the process of transferring to another person that we saw. And of course, it's only going to be another one person. And then what we have is operator approvals. So here, we're basically saying, I have an example here. It's a mapping from address to a mapping from address to Boolean. So it's pretty similar to what we saw here in terms of Bob allowing Jane to transfer 20. But here we don't have individual units, so we just have a Boolean. So here Bob is saying that Ankit can actually approve stuff, and it's true, which means that Ankit is actually able to move it. So now let's look at a simple constructor. So name, I just called it myNFT for class, a symbol, and I'll say the owner is the one who created, which makes sense. And let's say we have a URI, I just have a simple, I think this won't work. And then I'm emitting that there has been a transfer from the 0 address to this. All it's saying is that this just shows that I'm the owner, right? Because 0 address is not reachable. And then we have the same things called balance of that tells you if the token owner is the real owner, it gives you 1, otherwise it gives you 0. So it's a very simple thing. If Bob is the one and Jane is the token owner, Bob will receive 0. If it's Jane calling it, balance of, she will simply just get a 1. Yeah, and I'm going to go a bit fast because this is something we've already seen. And we have the owner of as well, which gives you, so you give it the token ID. So I quickly talked about having a token ID, and we only have one token, so we only have one here, and it returns who the owner is. So this is how we verify ownership that we talked about before as well. I will stay away from safe transfer for now. We'll just come back to approve, and in approve, what we're just checking is whether the token ID that they're sending is valid, whether approval, we're trying not to approve the same owner. So I put some additional ones to show you, but this is not strictly necessary. But then what we need is, we need to check if the message sender is the one who is the owner. So the one who is calling the approve functionality is actually the owner, because if I own it and you're calling this function, it shouldn't work. Or that the person calling this function has also been approved, right? So if I approve you, you can then approve someone else because I'm giving you the delegation power, right? And that's what this is. It has been approved for the owner message. And then if that happens, we're basically saying token approval to 2. 2 is the address that is now has been approved. And I have some, this again is set approval for all. It's not something we need to really look at now because we only have one token, but think of this as just approval at a larger scale. And then I have some private functions. I would highly suggest to go over these because they're not, I wouldn't say that they're conceptually complicated because we're still building off from what we learned from ERC20. So it's just more just software development in that process. Saying that it's going to be, we're going to have a small transfer function and we're just going to check whether the token ID is valid. If the transfer of the tokens is not done by the owner, and transfer to 0 address as well. So just some basic checks that we didn't have in the ERC21. Yes, and then let's quickly look at what I mean by safe transfer from. So this is not something I implemented a lot here, but a safe transfer from is a way that was put into the standard simply because it's an NFT, there's only a single owner. So if you accidentally, for example, send it to the 0 address, it's gone, right? It's the same problem that we had in the ERC20 tokens as well. So the way this works is usually you would have more custom code in the safe transfer. So all this is doing is just checking whether the token is valid, and then the person who is trying to transfer it is either the owner. If I own it, the NFT, of course I can transfer it. Also, if I've been approved it, I can also transfer it. So that's all this is checking, nothing more. And then we call the safe transfer function. And as you can see, there are actually two functions here. The only difference is there's something called data, which you can send in, and that can just be something you verify before you transfer. Right? I know I'm speaking a bit high level now, but let's say that you want to transfer this NFT to another smart contract. Then the other smart contract can actually use this data in some capacity to verify. It could be a signature, it could be something. It's not really restricted, so that's why my explanation is also quite vague, because you can use it for a lot of different things. It's up to you. And then we have the classic transfer from one, where we're basically just transferring NFTs from one to the other. Yeah, I have definitely rushed most of it, but are there any questions? I think we have a few minutes left.
Students, you can share your queries, or if you feel that you need time, anything you can share, so that we can have a conclusion.
And maybe the people who have worked with NFTs, I think there is one project presentation where they have created NFTs for anime, right? Something like that. Yeah. They can also,
yes, sir.
Yeah.
Yeah, Vedant and Ujjwal.
Yeah.
Are you there, Vedant? Is anyone?
Ma'am, one doubt. Let's say I'm trading, I'm purchasing some NFT. How can I assure myself that a rug pull might not happen with that NFT or with that project?
What would happen? Sorry?
A rug pull where, let's say, it's stored somewhere else and someone has access to that link. Like sir said, maybe we have a hash pointer which can tell us that the data is changed, but is there a way of guaranteeing that we might not get scammed when buying an NFT and then one day I just open and it's not there?
Yeah, so at least from my point of view, I don't think there is a guarantee. And this is a bit of the difference between ERC20 tokens and NFTs, where because it is referring content outside, you can never really guarantee that you're getting what you're buying. But at the same time, after having said that, that is why you see a lot of companies who do produce NFTs or foundations. They're actually very visible because they're there to take responsibility if something happens. So now we've come into a bit more of a different structure where there are just companies outside of the blockchain who use the blockchain for NFTs. So in that case, you can say that, okay, if it's a company that's well regarded, then you can ensure that that the NFT you're buying is legitimate. But there have been cases where they bought scammed ones, and there is still more space for improvement there.
Yeah. So let me comment on that. It's a good question. There are two things in the NFTs, right? The NFT, in one sense, you have some kind of digital or some kind of asset. It could be digital or it could be physical asset, like for example, Mona Lisa painting and other kinds of things, or it could be some other
Sorry,
asset.
sir.
Right?
Can you repeat?
There are two. Yeah. So there are two things. We have to see in the aspect of two different things. In case of NFTs, NFT is like a pointer, or you can say some kind of record or transaction record or something like that, which could be pointing to a resource outside. For example, let's say that we create NFTs for Mona Lisa and things like that, right? So the question of scamming boils down to what is the underlying asset is, right? So if you think about the assets, then you still have this, how can we make sure that somebody is stealing or scamming and other kinds of things. If you look into the NFT, which is a kind of digital trace put onto the blockchain, this is like some kind of transaction which shows that you are the owner, right? Or at least proves that the ownership of yourself for a resource or something like that. For example, take the first tweet made by the Twitter founder, right? So it has been bought by someone and they created an NFC for it and things like that. And then what does it mean? It shows the authority of himself. And on the other hand, if you have a resource which is outside and maybe expensive painting or something like that, and then you have to make it verify with other means. So yeah, that is the one thing. And in case of hash pointers and things like that, so the reason why we have this hash pointers mechanism is that you can store outside the blockchain, and then what it guarantees is the storage location and the data is not tampered with and things like that. So if people, again, most of the NFTs is also hard to understand in the sense that they are linked with the emotion, right? So for example, what is the value of the first tweet? It's a bunch of characters and 140, the first, of course, the first tweet, right? Everybody knows what it is there in the first tweet and in the content, they can see it. But where did the value come from? The value comes from that it's Ramesh saying that I own this first tweet. It's like you can say that the rich people want to show some show off or something like that, because that's why they buy expensive painting, which is costing crores and crores of rupees and things like that. So many times you have to understand this emotion, which is linked to the value and things like that. So then you can also you can have all sorts of cons and other kinds of problems. But maybe let me put another comment on that. Of course, on one hand, you have NFTs for very, very silly reasons and silly things and stuff like that. But on the other hand, look into the future. Probably NFTs is going to be like for example, let's say that when you buy a house, you have a registration document, right? Which is in a paper form and things like that. What does it guarantee you? It shows that you are it shows a proof saying that you are the owner of the house, right? Maybe in the down the line in 10 years or in future years, probably you don't have any pen and paper, or you can say you don't have these kinds of paper. But on the other hand, what you have is you have a transaction or NFT showing that, okay, you own this house, and people can verify that one, right? So those kinds of things probably it might evolve into that direction, things like that.
Yes, sir. NFT ticketing is also like gaining pace right now.
Yeah. Okay, any other questions or comments? Otherwise, we can close the session and Siddharth, you are done with the NFTs as well, right? So everything is done. So on Monday, we can go with the project presentations. Then we can relieve Siddharth and
Yeah.
Thank you so much, Siddharth. And I think I think you.
Thank you both of you.
Yeah, thank you.
Yeah.
Okay, I will copy the slides and also the recording later, and also the code to the folder. You can. You can.
Yeah. Okay.
Good night and have a nice weekend.
Yeah. Good night. Bye-bye.
Yeah. Good night, both of you. Thank you.
Good night.
Thank you, sir. Thank you so much.